Hello all, welcome to my channel. Let's continue with the C# interview series. We have completed link you in our previous classes, and today we will be starting with the asynchronous functionality in C#. So if anybody is coming to my channel for the first time, please do subscribe and do check out my previous videos as well. So if you have any doubts or even if you like the video, please mention it in the comment section. So let's start with asynchronous functionality in C#. So if you before starting with asynchronous, we have to first know what is synchronous. So synchronous is nothing but it is a sequential flow. So program gets executed line by line. So basically the control flow of a program is called thread. And as for example, I'll show you the program here. See, for every program there will be a control flow, like here if I run this program and put a debugger, you can see the flow, right? Our control came to 7th line, and then it is moving to 8th, and then it is moving to 9th. So this is the control flow, and this flow is called thread. As for synchronous, there will be only single thread, and that is a single flow, and that flow is called main thread. And as main is the starting point of the program, and we call that flow as main thread, and that single flow is line by line execution. If you see here, our flow came at 8th line, and then it is moved to the 9th line, and then it is moving to the 10th line. So this is called the line by line or sequential execution of a synchronous program. So it moves to the next line only if the first line is executed completely. So it will not wait for that line to be completed. Let me run this again and show you. So here if you see, our main thread started at 7 and it is moved to the 8th line. So in 8th line we are calling one another function called pour coffee, and here we are just printing to the console. So it is moved to the 9th line. After, so if you see, 8th line is executed properly, so it is moved inside that function and the console is printed, and then only it is moved to the 9th line. So this is the synchronous functionality. So it makes sure every line is executed completely, then only it moves to the other line. So that is synchronous feature. Basically it exists in every program, every programming languages. So now let us convert our sequential flow into asynchronous flow. So how to do that? So I'll first convert it into the asynchronous flow, and then you will understand what improvement does our asynchronous features in C# has brought. So here asynchronous is nothing but parallel execution happens, for your clarity. So in synchronous, I told you, line by line execution happens, and for every line only after its completion it moves to the next line. That is synchronous. But in asynchronous, it will not wait at every line for its completion. It will start that task and it will immediately move to the next line, and in the background that task will be running. So that is what, so parallel execution happens in asynchronous. So let us convert our synchronous code into asynchronous, and for that we use async and await keywords in C#. So let us convert our code. So here if you see, asynchronous code blocks the thread until the task finishes. See, as I told, the main thread is blocked at a particular line until it completes. And asynchronous is nothing but it allows the main thread to continue executing another lines even the current line is taking more time. And async and await keywords I'll tell you now. So here we have to add async at method levels, which tells that the code inside this method is running asynchronously. So here we have to write this keyword async and its return type. So basically return type would be task if it is void. If it is any other type, you have to just enclose it inside a task, which is a generic type. So here whichever data type you wanted to return, you can give. So here we are not returning anything, so it is task only. and let us convert all these methods into async methods. And here we are not returning anything, so it is task. So this is the significance of async keyword. It will just convert the existing synchronous method into asynchronous. So okay, let me run this and show you. So controller came here, I added async, but here if you see, control is moved to the next line, but still console is not printed. Now let me, so here if you see, coffee is ready, this is printed first. So this line, we reached this line first. So when I click the next line, this pour coffee task is completed. So then as it is running in the background, once and when it is completed, it is printed on the console. So this is how asynchronous works. If I make this async every it runs in a asynchronous fashion. It will not wait at every line for its completion. So that is the significance of async keyword, and here we are using task as the return type. So there is one more keyword called await. So if I add await, what I am telling is, I am explicitly telling, even though this is asynchronous flow, I wanted this result of this method. Please pause main thread, complete this line, then only go to the next line. So that is what await does. So we pauses this await keyword pauses our main thread flow, and it will wait for the result of this method. So that is about await. So async keyword modifies a method that contains asynchronous operation, and await, it pauses the execution of the current task and waits for that task to be completed. So basically asynchronous advantages: performance improvement. Many tasks will be running on parallel and no resource or no UI will be blocked. Responsiveness will be good. And let me talk about multiple tasks. Now here await I have added, so I hope you understood. Now here nothing complicated. We have just seen three topics: async keyword, await, use of async, use of await keyword, and the return type. So now what I am trying to do is here I am just if I wanted to start all this, here I am externally calling pour coffee method and fry eggs method. So I wanted to start this two tasks in one go, like I don't wanted to call it one after the another. So in that case I can do one thing. See, I can create a task, or I can create a list of tasks. So task is nothing but a data type only. It will just save all the tasks, and I can save it in the list. So what are my tasks here? I wanted this pour coffee method and fry eggs method to be started at one time. So I cannot move out of the, okay, so here what it does is, here I, in this task object, all my tasks are saved. So task is nothing but it is just a data type to save any kind of asynchronous task. So here I saved it in my list. Now task dot, I'll just iterate over a loop, and task dot, so inside this count greater than 0. So what I would do is, I would check if any task is completed. For that I can use okay, so task dot when any, we will just check if any of the task is completed. So what does this when any does is it will just check our list of tasks. So this eighth line, what it does is it will call pour coffee and fry eggs in this eighth line itself, and in the background pour coffee method will be called and fry eggs method also will be called, and both of them will be executed parallelly. So after when by the time it reaches 15th line, if any both might have been completed or any one might have been completed. So we will just iterate over this task and we will just check if any of the task is completed. So task dot when any, and if you give list of task, it will just return us the list of tasks that is completed. So it will give us the first task that is completed. So now we will just await this finished task just to make sure that it is completed, and then we will remove our finished task from the list. So now I'll remove the debugger. So I will just see both of the methods are called at the same time. So one take I'll just give more time here. Okay, but pour coffee takes 3 seconds and fry eggs takes 2 seconds. So let me run this. So coffee is ready, eggs are ready. So these two lines are printed. Coffee is ready, eggs are ready. And let me put a debugger here. And if you see, eggs took take only 1 second. Both of the methods are started at the same time. So which will be completed first? Fry eggs, right? Because it takes only 1 second to complete. So that is why inside eggs preparing method, that task is completed first, and then pour coffee task is completed. So this is about task dot when any. So task dot when all, it will return only when, it will just return a boolean if all the tasks are completed or not. So awaits for all the tasks in a collection to complete before continuing. Task dot when any, it waits for any task in a collection to complete and then returns that task. So this is about task dot when all and task dot when any. And return types that are used here are task and task data type, as I showed you here. And there can be two types of operations. One is IO bound and another is CPU bound. Okay, as I said, there will be two types of operations. One is IO bound and other is CPU bound. So IO bound kind of operations are if you are trying to connect to the external database, or if you are trying to get some data from external sources. So that kind of operations would be IO bound. And if you are trying to make any intensive calculations, or if there are any expensive calculations, then that would be CPU bound. So basically for IO bound, the best option is async and await would be the better option to use with IO bound operations. With CPU, for CPU bound, we can there's one more functionality called so we can, for CPU bound, we can use task dot run. So here if you see IO bound operation, when your code needs to wait for external data, maybe any network request, like if you are calling any external API or database access or even file input, file reading data. So here using await and async directly would be the good option. For expensive calculation, that would block our entire functionality though. So in that case, task.run would be the better option, because it will not it will be entirely independent of the current context. It will create a new thread from our main thread and it will run it in the background. So that is task.run. So what is the difference between this async await and task.run? So async await is nothing but see, first there will be a main thread, right? So main thread will be executing. If you put async, then still main thread only it will be running. If you add await inside an async method, what it will do is main thread will be stopped for some time, and it will just check for any other thread, and that thread will be executing, that thread will execute our external that thread will execute our await method, but till then main will be in paused state, and after our execution is completed, then our main thread will be continuing its task. Here main thread will not be blocked, it will just be paused, so it will be available for any external activities, so that our responsiveness will be there. So main thread will be able to handle any other tasks also. For example, I'll show you here. Here our if I block our application with one API only, and if I don't give async await keyword, and if I in synchronous way only I am running, if you think, and if I block my code and it is taking so much time, in that case main thread will be blocked, I will not be able to run any other API also. So that is the advantage with async and await. So main thread will not be blocked, it will be just paused, it will be able to attend any other activities apart from the current code. So you can run any other API also parallelly. So that is the use of async and await. And task.run is also same thing, but here it will create a new thread, main thread will be doing its job. If task.run comes into picture, then it will create an entirely new thread which is completely independent of the current context of the main thread. So here it will be a bit tough, so that task.run is basically not in use generally. In most of the cases it is avoidable, so await and async would be direct and easy, and it would be satisfying most of the applications needs in real time. So this is about synchronous and asynchronous. And did we miss anything? Okay, let me tell about whenall as well. So here when any of the task if I give, it just returns the finished task, and we can, if that task is not completed, then we are awaiting. Why here we are awaiting means, if it is already finished, fine, but if it's still, then we are awaiting, and then we are removing that finished task from our task list. So here await when all is, so it will just wait for all the tasks to be completed, then only it will move to the next line. If we wanted all the tasks to be completed, then it will move to the next line. Here instead of this we can do one more thing also. Instead of adding it inside a list, I can create a task object, coffee task equal to, and I can do same thing for this also. I can just create our task in an object. So I can give x task equal to, and here instead of putting a loop and awaiting it, I can await coffee task, and I can await egg task. So this is also another way. So instead of redundant code, we can just put this tasks in a list and then await them in a loop. That is also another option. So basically I hope you guys are clear with asynchronous functionality in C#. So synchronous line by line is executed, and it will not wait, in synchronous it will be waiting for every line to be executed. In asynchronous that is not the case. We can start time taking processes in one go, and there's no need to get it executed one by one. We can start them in one go, and whenever needed only we can await them. So in the background that task will be running only. So this is about asynchronous functionality in C#. So please subscribe and comment if you like my videos, or comment if you have any suggestions, or comment if you have any doubts as well. So please like, share and subscribe. Thanks for watching. Stay with me for more content on C Sharp full stack, .NET full stack development. And thanks for watching. Thank you guys.